Wish it was good as yours. All right. How can you factor special products, kids? We're going to go back to some things that we talked about in 2.3. And we're going to try and combine and work backwards from what we did in section 2.3. But in order for us to do that, we need to remember what 2.3 was all about. So today we're going to be talking about factoring special products. Now here's the deal. If you don't like these shortcuts today, can you still go back to what you were doing to factor stuff? And the answer to that is going to be what? Absolutely. All right. So I'll look at a couple of different cases here and kind of let you decide. But kids, the essential question is this today. No! Don't do this to me. All right. How can you factor special products? So we're looking at factoring the difference of two squares, factoring perfect squared trinomials, and we're going to use factoring to solve real life problems. Okay? Kids, I have a quick question for you. Recall this. When factoring the difference of two perfect squares, here's the deal. Do you guys remember when we were foiling stuff out and we were multiplying all that stuff together? You remember doing that? Okay. Yeah. Oh, things are not going well up here this morning. Okay, so when we did, remember when we FOILed out a minus b times a plus b right here? You guys remember doing that? So what would the a times the a have gotten you? Okay, and then think about your inside and outside terms. Your outside term would be a plus ab, wouldn't it? Wouldn't your inside term be a minus ab? So what did they do to each other? And then what did the negative b and positive b make? Okay, so here's what we're going to try and get you to notice today. As an example, suppose I had something like this. This says factoring the, what's the word difference mean? What operation? Subtraction of two perfect what? Well, what they're kind of saying is this. If you ever have a squared minus b squared, that just factors back into a minus b times what? So as an example, suppose I had, I don't know, suppose I had 4x to the second minus 36. Okay, guys, think about that 4x squared. Is 4 a perfect square? That's my first question. What is the square root of 4? 2. Okay. What's the square root of x squared? Wouldn't that just be x? So in factored form, this would factor into 2x and 2x, wouldn't it? Doesn't that make the 4x squared? And now that I have this minus sign in here, isn't 36 a perfect square? Okay, what is the square root of 36? So I can write this as minus 6 times plus 6. There it is. 2x minus 6, 2x plus 6, if I wanted to. Pretty interesting, right? Let's go right down to example 1 with this idea. Guys, this only works when you have what sign right here? A minus sign. So what is the square root of x squared here, kids? So this is just going to factor into x and x. And then by rule, it's going to be an a minus b and an a plus b. Well, isn't 64 a perfect square? So what? Plus 8 and minus 8, right? So you guys try this one over here. Now again, this is only going to work if what sign is between these two perfect squares. You guys try that one. This is going to be the difference of two perfect squares right here. How do you factor the difference of two perfect squares? Well, can you think of two numbers that multiply to 121? 11. Okay. So this will factor into 2x's. What are you going to have in here, kids? Minus 11 plus 11. Now I'm going to go over to the board over here and say, if you didn't like this method right here, here's what you could do. This is like x squared plus 0x, isn't it, kids? Minus 121. Do you agree with that? Okay, watch what I do here.
What value's out in front of the x squared, kids? If I didn't like doing that, or if I didn't see the shortcut, I could still do 1 times what here by our rules from the past. So on your calculator, you would go what value for product? And what value would you go for sum since there's no middle term? 0. And what this would kick out would be a plus 11. And anybody want to guess what the other one is? And here's what you would split it into. You would split it into x squared plus 11x minus 11x minus 121. And here's what would happen when you split it. What's going to come out of the left here, kids? Couldn't I take an x out of both of those? What's left? Okay, and then I take a minus 11 out of both of these. Kids, did my x plus 11s match there? What parts are out front here? Well, the x and the minus 11, so that becomes its own group. Doesn't that get us right back here? So if we don't see the shortcut, do we still know things about factoring to be able to solve or factor still? Absolutely. Okay. Let's talk about this next one right here, kids. This factor says factor 25b squared, and again, there's a minus sign here. Perfect square, perfect square. What's the square root of 25b squared going to be? So it's going to become 5b times 5b. There's no middle term, so it's a difference of perfect squares. How about the square root of 36? So how about a plus 6 and 11? Think about it, kids. Look at your outside. What's 5b times negative 6? Negative 30b. Inside would be positive 30b. What do they do to each other? So that's why there's no b term in there. Okay? You guys try this one. I'll try and think of a tough one. 49, best letter in the alphabet squared, minus 81. Go. Anybody have it? Mr. Andrew, what do you think?
In parentheses 7p minus 9, then in other parentheses 7p plus 9.
Show of hands, how many agree? I love it. Okay. This only works if the two values in this are both perfect, what? What's the word I'm using? Squares, and there's what sign between them? A minus sign, okay? So that kind of covers the first example up here. So we need to come back to the second one right up here then. And this one here says factoring perfect square trinomials. Now kids, I'm going to use this idea right here. You guys remember when we did a plus b to the second power, which meant a plus b times what? Itself, right? And when we expanded this, the shortcut was a squared plus 2ab plus b squared. Likewise, we also talked about having a minus b squared. That there became the following. It was a squared minus 2ab plus b squared. So as an example, kids, here's kind of what we're getting at. And this will be the one that's, if you see a trinomial and you want to go, oh boy, and you want to go back to what's happening here, we'll be good. We're kind of in a twilight zone today with that going on and off, aren't we? All right. Let me give you an example. Let's do x squared plus 10x plus 25. Can I give you a hint about this right here, kids? Is that okay?
Yes.
All right. When we're doing these right here, what you want to do is kind of look at your first value and last value. And these special ones right here, look at your first value and look at your last value. And ask yourself the question, okay, are those things perfect squares right there? Is x squared a perfect square? The answer would be what? Yes.
Yes, because 1's a perfect square and x squared is a perfect square. And then ask yourself, is 25 a perfect square?
Yes.
Okay. Guys, we've talked about this in the past. Can you think of two numbers that multiply 25 and you have a 10 in the past? 5 and what? 5 and 5, right? Okay. This, my friends, is actually factored into x plus 5 times x plus 5, which would simply be x plus 5 times itself. How many times, kids? This would be your factored form right there. Okay. So if you see the first term, if you have three terms like this, the x squared, the 10x, and the 25, if you notice that the first term and the last term are perfect what? Squares, there's a good chance that it's either this one or this one here. Okay? If it's a plus sign in here, it'll be x plus. If there's a minus sign in the front of the middle term, it's going to be probably what? Okay? So let's move on to the second page. Let's see if we can't apply this here. Now, I'm not worried about example 2 right now. Let's go to example 3 first. Okay, kids, let's just look at this first and third term and ask ourselves the question. Now again, if I didn't see this right here, could I do what we did in the last section and say, okay, 169. Who's got that calculator open right now? Punch in 169 for your product and 26 for your sum there, Allie. 169 for product. Oh, wait a minute. We get 13 and 13? That's good, because if they're the same like that, then you should factor into one thing and the same thing, right? Okay. Guys, isn't 13 the square root of 169? So this will just simply factor into x times x. Okay, what values am I going to throw in there? Okay, check this next one right here. Let's see if this works. Is this a perfect square?
Yes.
Is this a perfect square?
Yes.
Okay. What's 9 times 16? $144, right?
Yeah.
I'm not even going to go this route. We're going to see if it works here, guys. What's the square root of x squared? How much?
X.
Careful. Square root of 9x squared.
Oh,
3x and... Now, kids, we have a plus 16 out here. Isn't 16 a perfect square? Okay. What's the square root of 16? So am I going to use a plus 4 or a minus 4 for both of these? Now, kids, here's the deal. This term has to be 2 times a times b. Right there from that special formula. Guys, the a value is 3x. What's 3x times negative 4?
Negative 12.
Negative 12x. What's negative 12x times the 2 in that part of the formula?
Negative 24.
Is it right? Sure is, isn't it? Right? Now, with these two right here, I would probably factor this into x plus 13 to what power, kids? Yep. I'd probably factor this into 3x minus 4 to what power, kids? Okay. What do you think? Are you listening on this right now? And again, if you don't like doing this right here, the shortcuts, can't you go back to what we've been doing? Okay, I could have said 1 times 169 is 169. I could have said, all right, two numbers that multiply to 169, 26, or 13 and 13. I could have written my 3-term trinomial as 4 terms, replacing the middle term with the 2 values that you get. Split that factor, you would still get the same thing. All right, so let's use this idea to solve some equations, kids. First things first.
Is x squared a perfect square?
Yeah.
You bet it is. How about this 9/4? Is that a perfect square?
Yeah.
What is the square root of 9/4? 3 over what?
2.
Square root of 9 up top would be 3. Square root of 4 on the bottom would be. Okay, kids, this is going to turn into x. Let's see. And x, that's the square root of the x part. What's the square root of, you said 3 over 2? I'm putting a plus sign here because that's a plus sign. Hey, quick question, kids. Help me out with this middle term. What's 3 over 2 plus 3 over 2?
6 over 2.
6 over 2, which simplifies to what value? So when I do the inside 3 over 2x and the outside 3 over 2x, doesn't that simplify to 3x? So stuff is factored correctly. So to solve this now, kids, we would take both parts, x plus 3 over 2, and set equal to what? Well, how many times do I need to set this equal to 0? Well, really one time. What's the solution going to be here, kids? Say it again, Corbin.
X plus 3 over 2 to
Okay, I would, yep, to the second would equal 0, but if I'm solving this right here, I can set each part equals 0 now. We've got a 0 product going on. So if I set this first part equal to 0, kids, what's the x value going to be when I subtract 3 over 2 from both sides?
3 over 2.
Yep, negative 3 over 2. So I agree with you. You bet, Corbin. Good observation there. And then I want to go in and solve those. And how many times am I going to get negative 3 over 2, kids? Twice, right? You guys remember what kind of solution that was called? Starts with an R.
Relative.
Close. Something that happens more than once. If we were saying it gets repeated solution. Okay? You would have a repeated solution. Help me with this one. What's this going to factor into? Is a squared a perfect square? Is 9 a perfect square? What's the factor into what then? Anybody?
A plus 3.
A plus 3 and
A plus 3.
still equal to? Well, what's my solution going to be here?
A equals negative 3.
Kids, I know I'm going quickly, but just give me a show of hands. Are you on board with me right now? Kind of fun to ride the wild train, isn't it? Yeah.
How did we get negative 3?
Say that again.
How did we get negative 3?
So what we do right here, since it's an equation gauge, we have to set a plus 3 on the left equal to 0. So if I solve this right here, what would the a value equal there?
3.
Say again.
3.
What number plus 3 would make 0?
Oh, negative.
That's where we're at, okay? That's how we got that to solve that, all right? You with me on that? Good question. Good question. All right? Who's ready to rock the next example here? Get this stuff done. I'll give you a little time to finish up with work, all right? Okay, here we go. Last example. We've got a pesky bird in this next example, okay? You guys see this equation down here? Might want to circle that. Okay? Okay, how about a volunteer to read my example 5 here? Anybody want to read that for me this morning?
Bird picks up a golf ball and knocks it while flying. The function represents the height, y, and feet of the golf ball t seconds after it is dropped. The ball hits the top of a 17-foot tall pine tree. After how many seconds does the ball hit the tree?
Okay, so it hits the pine tree, but the pine tree is how far in the air, kids?
17 feet.
Okay, so we have this pesky bird that stole a golf ball right here, and it says it dropped a golf ball, and the height y of the golf ball can be bound by 81 minus 16t squared, right? Okay, so I'm going to go down there and write the height of the ball after any time t. So I'm going to write down y equals, what was it, 81 minus 16t squared, kids? Okay, so the question says, at what time t was the ball at the top of that tree? Well, how high in the air is that tree, kids? So basically we're plugging in y values. A y value is the height. Right here we need to replace y with what value? Okay, let's do that. So we're going to have y equals 17. Crazy today. Okay. Now, kids, we know we can only solve an equation if our equation, or I should back up, we know we can only factor to solve if our equations equal what value? 0. So I'm going to cheat on this a little bit. I'm going to take what's on the right side and move everything to the left. So I'm going to subtract an 81 from both sides. What's 17 minus 81? Is it negative 64? Somebody check on that. 17 minus 81.
Yeah.
Okay, this would equal negative 16t to the second. All right, so I'm going to go ahead and add 16t squared to both sides. Here's what I end up with, kids. I end up with 16t to the second minus 64 on the left equals what value on the right now?
0.
Right? Well, all right. We need to solve this. But guys, I'm going to go back to my front page here in a second. Is this like factoring the difference of two perfect squares or factoring a perfect, what's the word here? Well, this is just, how many terms are in this, kids? On the left side, how many terms are there? 2. Is this a plus sign or a minus sign?
Minus.
Is this a perfect square?
Yes.
Is this a perfect square?
Yes.
This is going to factor into the same things. One's going to be a minus sign, one's going to be a plus sign to equal 0. What's the square root of 16t squared? 4t. Right?
Something's different this time.
I think this thing was made by the Ford company.
Uh-huh.
J-U-N-K.
Junk.
Junk. I'm going to set both parts equal to what value? And when I solve for t, that'll tell me how many seconds when he dropped the ball up there, how many seconds it took to get to the top of that tree. All right, so here we go. I'm going to set 4t minus 8 equal to 0, kids. And I'm going to set 4t plus 8 equal to 0. Help me solve this one over here on the left. What's your t value? T would equal positive 2. What's this going to equal over here? Negative 2. Now, kids, we're talking about a real life problem, so really the idea is how many seconds did it take for the ball to hit the top of the tree? Am I going to worry about the negative 2 as a solution? All right. So we would say, therefore, since t equals negative 2, or I'm sorry, positive 2, it took how many seconds to hit the ground? Around, I don't want to say the ground, the top of the what? 2 seconds to get to the top of the tree. Now, guys, I was pretty speedy through that, but I would just kind of look back at your rules on this today. Again, if you don't see the shortcut, what can you still fall back on, kids? The way we factored in the beginning. Okay, you have multiple ways of factoring stuff. This stuff only works if the first term and the last term are perfect squares. Okay. All right, I'm going to stop here, kids. Any questions?